All right, welcome back. We are picking back up under Roman numeral number 2 in your lecture notes, and we are going to discuss letter D, which is the cardiac cycle. So when you hear this term, the cardiac cycle, think about all of the steps that are taken during the course of one single heartbeat, okay? So during one heartbeat, there are periods of contraction and relaxation within the chambers of the heart, okay? So a complete cardiac cycle, one complete cardiac cycle is equivalent to one heartbeat, okay? And there are 3 phases of contraction slash relaxation that occur within the heart to allow for the heart to beat one time, okay? So if you were to put your hand on your chest and close your eyes and just feel your heart beating, you're gonna feel this thump, 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 okay? That thump, thump is one heartbeat, okay? And you're hearing that sound, which is a twofold sound, the thump thump, because you have two sections of the heart contracting right on top of each other, okay? It's a cyclical contraction, right? That first starts at the atrium, okay? So both the right and the left atrium will first contract simultaneously, okay? And what do I mean by contraction? I mean that the specialized cardiac muscle that is surrounding the chamber of that heart, so right here on the right here on the left, okay? That cardiac muscle will contract and it's going to tighten up, thereby making the chamber smaller, okay? That contraction is that first kind of heartbeat sound, all right? It's actually associated with the valves, the heart valves snapping shut, but the heart valves snap shut because of that contraction, okay? So this first part of the cardiac cycle are the atria on the left and the right side are going to contract simultaneously at the exact same time, okay? Remember, the heart is kind of broken up into a right and into a left quadrant, okay? So everything that is happening on the right side of the heart is also happening on the left side of the heart, and you do not have crossover of blood between the right and the left side. So the contraction of that right and left atrium is going to push blood from the atrial chambers or the upper chambers of the heart down into the ventricles, okay? Once the blood is down in the ventricles themselves are going to contract, okay? You have this muscle group down here for the right side and the left side, okay? Contraction of those ventricles simultaneously is going to act to squeeze all of the blood out of the chamber, just like toothpaste out of a tube when you're squeezing it. The blood on the left side is going to get squeezed out into the aorta, and the blood from the right side is going to get squeezed out into the pulmonary arteries. All right. So after the muscles around the ventricles are finished contracting, all muscles in the heart go into a state of relaxation, okay? So the 3 phases of the cardiac cycle or one heartbeat is contraction of the upper chambers of the heart, okay, or contraction of the atrium. The second phase is contraction of the lower chambers of the heart or contraction of both ventricles simultaneously. And then finally followed by a state of relaxation across all of the cardiac muscle, okay? 1, 2, 3. That is considered the steps within a cardiac cycle, okay? There is a more technical name that we use when we're referring to periods of cardiac contraction or cardiac relaxation, and that would be either systole or diastole. So make sure you start to get familiar with these terms because we're going to start referring to systole and diastole rather than contraction and relaxation, okay? Oops. Sorry. Okay, so systole is a terminology for a period of cardiac contraction. Okay. And what happens during contraction? The muscles tighten and that chamber decreases in size. Okay. So the muscles tighten, heart chamber decreases in size, which will then lead to an increase in blood pressure inside of that heart chamber. This is a very important phenomenon to understand, right? So as the size of a vessel, or as the size of a chamber decreases, the pressure inside of that chamber is going to increase, okay? So there is an inverse relationship between size and pressure, volume and pressure, okay? So as the volume of the chamber or the size of a chamber increases, the blood pressure would decrease, or vice versa. If the chamber size decreases, the pressure inside increases, okay? So it's this phenomenon that's really allowing for the blood to get pushed forward within the cardiovascular system into that next segment, okay? So through this systole or contraction of the heart muscles, the heart chamber decreases in size. That will then allow for the blood pressure to rise up, and the pressure of that blood is so high that it's forced out of the chamber and into the blood vessels, okay? So any type of systole that happens in the upper chambers of the heart, this is called atrial systole. So during atrial systole, both of the atria contract, all right? So this includes the right and the left side. That will then cause the AV valves to open and the blood to be pushed down into the ventricles, okay? So this is the first step, or the first stage of the cardiac cycle. After atrial systole, you're going to have ventricular systole, which is the contraction of the lower heart chambers, or the right and the left ventricles. All right. So contraction of the right and the left ventricles will cause the AV, or the atrioventricular valves, to close and those semilunar valves to open, right? And this is very important right here, this little piece, that the semilunar valves open, because that will then allow for blood to move into the vessels. So it allows blood to move out of the heart and into the vessels, which is the whole point of this anyways, right? The heart is truly just a pump to try to push blood from one area of the body to another, okay? And the blood is moving or traveling through a series of these tubes called blood vessels. And the heart is just the force that is driving the movement of blood through these vessels. Okay, so that's really our ultimate goal here. So in order for this to happen, for the blood to leave the heart and enter into the blood vessel, that semilunar valve needs to open, okay? Once this has been accomplished and the ventricles contract and push the blood out of the heart and into the vessel, the heart goes into a total state of relaxation, also known as diastole. So relaxation, okay? The heart is no longer contracting. That means that both the atria and the ventricles are relaxed. All the valves are reset to their normal position, meaning that the semilunar valves are closed and the AV valves are open. Right? So I want you to definitely understand what is happening in each one of these phases of the cardiac cycle, okay? So you need to know the position of the valves as well as the movement of the blood and whether the atrium or the ventricles are in contraction or not. So I drew this up a little bit in more detail so that you could get a visual of what's happening at each stage, okay? And like I said, you're responsible for knowing at each stage of the cardiac cycle the position of the valves, both the AV and semilunar valves, as well as what direction the blood is moving in based on the state of contraction or relaxation, right? So let's go through this one more time using my lecture drawing here. So atrial systole. Remember, atrial systole is referring, sorry, I guess we'll keep the blue. Okay. Atrial systole is referring to contraction. Systole equals contraction. Contraction of both atria, right and left, simultaneously, okay? So during atrial systole, the right atrium and the left atrium are contracting simultaneously. Okay, so let's see what that looks like in the heart. So this is kind of your starting position over here on the left. This is where we're starting, okay? So what's happening in this current picture? We have blood traveling into the right atrium of the heart, and it's traveling from the body carrying deoxygenated blood, okay? So this would be blood from, oops. So this would be blood from the body. And it's going into the vena cava, right? That blood from the body enters into the right atrium, okay? Now you're going to have a collection of some blood in that atrium, but you're also going to have these open AV valves that are lying between the atrium and the ventricle. So the AV valve on the right side is open. While it is open, that means the blood is not only collecting in the atrium, but the blood is also starting to collect and pool inside of the right ventricle, okay? However, it is not leaving the right ventricle at this point in time. It is just starting to collect, and the volume of blood is getting higher and higher because this semilunar valve on the right side is closed, your pulmonary semilunar valve. Okay, so see how there's a big X there in bright green? That's referring to a closed semilunar valve. So that means the blood cannot exit at this point in time from the heart into the vessel. Okay, so what is the force or the mechanism that is keeping those semilunar valves right now? That closed right now. That has to do with the blood pressure inside of the vessels. Okay. So you have a very high pressure that the blood is under within the blood vessels, okay? So that means the blood pressure in the vessel is greater than the blood pressure inside of the heart chamber, okay? So if the blood pressure outside is greater than inside, that is going to keep that valve snapped shut, okay? So it's like 10 people holding a door closed, okay? Those 10 people are going to keep that door closed until you have more and more people on the other side pushing against you, okay? Once the force of the push against you is too great for you to be able to handle, then that door is going to open and all the people are going to flood out of the room, okay? So this is the kind of the same idea. You have enough pressure to keep that door or that valve closed, but as soon as the pressure gets bigger from inside of that room or inside of that heart chamber, the valve is going to open up and everything will flood out. Okay, so on the right side of the heart here, we have the AV valve open and the semilunar valve closed. Okay, now on the left side of the heart, remember this is where we have the blood returning from the lungs. Okay, the blood is going down into the left atrium. It's going to travel through this open AV valve. Okay, and then it's going to go and start to collect inside of the ventricle, the left ventricle. Here, the blood will not move any further because that semilunar valve is closed. And that semilunar valve is closed because of the high blood pressure that is inside the aorta, which is this vessel right here, okay? So that's kind of our starting position, right? So the heart gets its first signal to contract, okay? So the first type of contraction that's happening is contraction of the atria, okay? The right and the left atria are going to contract simultaneously, okay, which you can see over here. Contraction of the muscles around that heart chamber is going to cause a decrease in the size of the chamber, all right? Remember, when you decrease the size, when you decrease the size of the chamber, remember our inverse relationship between size and pressure. So as you decrease the size of the chamber, you are essentially increasing the pressure inside of that chamber. Okay, so contraction of both the right and the left atria will cause a decrease in the size of that chamber. That will then create an increase of the pressure that is being put on the blood, okay? So that blood is going to then move down through these open AV valves during atrial contraction, okay? The AV valves are open, so this is squeezing all the last drops of blood to start to accumulate here within the ventricles, the right and the left ventricles, right? However, at this point in time within the cardiac cycle, the semilunar valves are still closed, all right? So all the blood is just pooling inside of the ventricle, all right? So during atrial systole, both atria contract. Blood is squeezed through the open AV valves until it is all collected inside of the ventricles, all right? So that's step one. In step two of the cardiac cycle is ventricular systole, okay? So this is when the right and the left ventricles contract, okay? Same idea here. As you have that contraction of the chambers, the size will decrease, the pressure is going to increase, and that is going to move blood forward within the cardiovascular system, okay? So over here on the right, this is kind of where we left off on the previous slide about atrial systole. At this point in time, all the blood is accumulated. Oops. Sorry. At this point in time, all the blood has been accumulated within the ventricles, okay? Both the right and left AV valves are open at this point in time, and both of the semilunar valves are closed, okay? So that means we have all the blood down inside of the ventricles, but it's not ready to leave into the vessel, okay? So since these AV valves are open, how are we preventing a backflow of blood, okay? Theoretically, blood could start to flow backwards in that system and go back into the atria, back into the ventricles. Remember, we always want a forward-facing or a forward-moving system of blood going through the vessels, okay? So when this next step happens, it creates a twofold assurance to make sure blood is only moving forward within the system. And that happens during ventricular systole. So now the ventricles are going to contract, okay? When you have the contraction of the ventricles, the chamber is going to decrease in size. Did that again. It's going to decrease in size, which will effectively increase the pressure of the blood, okay? Now, at this point, the pressure of the blood inside of the ventricles becomes so great, it becomes greater than the pressure of the blood inside of the vessels, which then will force these AV valves to open up. Will force these semilunar valves to open up, okay? Because of the difference in blood pressure also, you're also going to see this snapping shut of the AV valves, okay? So this is a signature of the ventricles contracting. When the ventricles contract, those AV valves snap shut, the semilunar valves open and the blood moves out from the ventricle and into the blood vessel, okay? And this can only happen by changing the pressure of the blood inside of the ventricles through contraction or through systole, okay? So make sure you understand that as soon as those ventricles contract, these AV valves snap shut, the semilunar valves open, and blood is now flowing out of the heart and into the vessel because the pressure of the blood is now greater than the pressure that was in the vessel, right? So we finally have our forward movement or our ejection of blood out of the heart, okay? And that will lead us to our third and final stage of cardiac cycle, which is called diastole. During diastole, all chambers of the heart are now relaxed, okay? Their chamber sizes return to normal. The pressure inside of the heart returns to normal. The semilunar valves in response are going to snap shut, okay? Because now you have a greater pressure of blood on the outside of those vessels, on the outside of those valves compared to on the inside from the heart, okay? So the semilunar valves snap shut and the AV valves return to an open position, okay? So this is our relaxed phase, and this is where we started from the beginning, okay? So this is called diastole. This is complete relaxation of the heart. AV valves are open, semilunar valves are shut or closed due to the differences in pressure between the ventricles and the vessels, okay? So you will be responsible on your exam for knowing those three phases as well as understanding the positions of the valves, both the AV and semilunar valves in each one of those phases. So this is just another picture kind of reviewing the steps. I'm going to make sure I upload those lecture drawings to Blackboard so you can go through them one by one as well, okay? So let's get some questions in as a practice for what we just learned about the cardiac cycle, okay? So number one, a contracting heart chamber is in diastole or systole. So we just learned that heart contraction has to do with this terminology, systole, okay? So a contracting heart chamber is in systole, and a relaxed heart chamber would be in, we're going to say diastole, okay? That's the opposite of systole. Diastole meaning relaxation, okay? As the cardiac cycle begins, the ventricles are partially or completely filled with blood, okay? Remember, the ventricles are the lower portion, are the lower chambers of the heart, okay? So as the cardiac cycle begins, remember the heart is in complete relaxation, okay? The AV valves are open, allowing for some of the blood that's entering into the heart to go ahead and drip down into the ventricles. So we are going to say that it is partially filled with blood, okay? That ventricles are not going to be completely filled with blood until the atrium contract. Number three, what happens to the left AV valve when the pressure in the left ventricle rises above that in the left atrium? Okay, so let's figure this out. We have our atrium, we have our ventricle, we have our AV valve, and our semilunar valve. Okay, so this is asking what happens to the left AV valve when the left ventricle pressure rises. Okay, so as the pressure down here increases, that is going to forcefully snap our AV valve shut. Okay, and it is going to cause the opening of the semilunar valve. So what happens to the left AV valve? It is going to close under the force of higher pressure in the left ventricle. Okay. Number four, most of the ventricular diastole, during most of ventricular diastole, the pressure in the left ventricle is greater, less than, or the same as the pressure in the left atrium. Okay, so diastole is referring to a state of heart relaxation. If the heart is relaxed, okay, there should be no difference in the pressure between the ventricles and the atrium, okay? It's kind of a free-flowing movement. It's only when you introduce a contraction or a systole to this equation that you're going to have changes in the blood pressures. So during diastole, the pressure in the left ventricle is the same as the pressure in the left atrium. Number 5, what happens to the aortic semilunar valve when the pressure within the left ventricle becomes greater than the pressure in the aorta? Okay, so when the ventricle pressure gets greater than the vessel pressure, okay, that is going to cause the semilunar valve to snap open. Okay, so when you have a higher pressure on one side of the wall versus a lower blood pressure on the other side, relatively, you're going to be moving from an area of high to low resistance, okay, which is going to cause a opening of that semilunar valve. And we say aortic semilunar valve because it's on the left side and it's associated with that vessel called the aorta, okay? So that semilunar valve will open when the pressure in the left ventricle becomes greater than the pressure within the vessel or the aorta. Number 6, during atrial systole, the semilunar valves are in which position, open or closed? During atrial systole, that's contraction of the upper heart chambers. The purpose of this is to simply push blood down into the ventricles. However, the blood is not yet ready to move down into the vessels because of the pressure differences. So during atrial systole, those semilunar valves, which are at the tail end of the ventricles, at this point in time are still going to be closed. Okay, it's only during ventricular systole that the semilunar valves open up. And then finally, number 7, during diastole or relaxation, the AV valves, or the atrioventricular valves, are in which position, open or closed? So remember, during relaxation, we're in our kind of resting state there. During the resting state, the AV valves are always open and the semilunar valves are always closed. Okay. So that was our review of the cardiac cycle. Okay. In the next video, we're going to start talking about the cardiac conduction system, which is basically how the heartbeat is generated. Okay, what is the driving force that allows for the contraction of this cardiac muscle? Okay, so we have this electrical activity that drives the heart muscles to contract and relax at certain periods of time. Right, and then we're going to finish up by talking about blood pressure and the regulation of that blood pressure throughout the cardiovascular system. All right, and that'll be our final section for this chapter. All right.